Good evening, students. Uh, Today I will be taking your first online class. I am making video on Unit 3. In this class, I will be discussing a little bit theory before I start numericals. This presentation would basically on theory, theory related to the Unit 3, right? Before I start my class, I would like to request all the students to stay positive because outside condition is it is stressful and create positivity inside you and everyone around you. Um, we have to be strong from inside. So this is actually one thing which I want to say before starting this class, right? Let's start our class. The topic which I will be discussing today would be kinematics of a particle, velocity, speed, displacement, acceleration, which you already know about. I will tell it. Just try to recall these concepts. Then, what is rectilinear and curvilinear motion? Equation of kinematics, work energy principles, conservative and non-conservative forces, conservation of energy, impulse and momentum, and impulse momentum principle. Right? Let's go ahead. First of all, let's discuss what is kinematics of a particle. Right? Uh, Basically, kinematics of a particle is the study of a motion of particle without any reference to the causes of their motion. Uh, Before I talk about kinematics, first of all, I would like to tell you that in Unit 1 and Unit 2, we discussed on statics part of the engineering mechanics, where we studied uh, different different objects, uh, uh, different type of particle study when they were actually in static position that they are not moving. But now Unit 3 and Unit 4 are basically dynamics type of engineering mechanics where motion is studied. And now dynamics are divided into two types. One is kinematics, another is kinetics. Kinematics and kinetics, right? Now kinematics is basically a study of motion of particle when the causes of their motion is not studied. That what forces make that motion occur. We are not studying that. We are studying only the only motion of the particle, that what is the velocity, what is the acceleration, and displacement, distance. Only those things we are studying. We are not interested in the forces behind the behind this motion. But in kinetics, we not only study motion, we also study causes of the motion or forces behind those motions. So kinetics will be, I think, in Unit 4. Unit 3 is totally on kinematics. So here we will study kinematics of a particle. Another definition of kinematics is a subfield of classical mechanics that describes the motion of points, bodies, and system of bodies without considering the forces that causes them to move. Okay, now let's go ahead. Next topic is displacement, right? Uh, the displacement is the motion in which all the particles of a body move to the same distance in same time is called translatory motion. Okay, let's. This is not displacement. Dis as we know, displacement is a vector quantity and distance is a scalar quantity, right? Now, what do you mean by vector quantity of displacement? Suppose body starts to move from one point to another point. Now, let us suppose that uh, that 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 a point the point from where the object start moving is at 0. Now it moves to plus 5 in positive direction of x-axis and then come back to 0 and then to minus 3. So the total displacement will be first from 0 to 5, then coming back from 5 to 0, 5 plus 5 10, and then minus 3 13. Then the total displacement will be 13. But if we talk about distance, then they are not the path is not checked here, and we see that the distance would be only minus 3 or 3, not 13. So this is the difference between displacement and distance. So displacement is actually dependent upon initial position, final position, as well as how the movement of a particle happened. This whole everything will be studied in displacement, but distance is only interested in initial position and final position, not on the what not on the path followed, right? Now there are two type of translatory motion. One is rectilinear motion and curvilinear motion, which we will study later. Now next topic is velocity and speed. The velocity of a particle is a vector quantity which describes the magnitude as well as direction of motion of the particle. We already know that. Speed is the magnitude and not direction. It is a scalar quantity, and basically velocity is the rate of change of position with respect to time. So we know that velocity is a vector quantity, speed is a scalar quantity. Velocity gives a magnitude as well as direction both. Speed gives only uh, only magnitude, not direction. Right? Now let's go ahead. What is acceleration? Acceleration is actually um, gives the magnitude of velocity vector and the rate of change of direction of that vector also, and it is the actually first derivative of the velocity vector and second derivative of the position vector of that particle. This is also again a vector quantity. So here I have discussed displacement, distance, velocities, speed and acceleration. These things I wanted to recall because this will be used a lot in further studies. So let's go ahead. Now there are two types of motion, as I already told you. One is rectilinear motion, another is curvilinear motion. What is rectilinear motion? It is a linear motion. Suppose some particle is moving in a straight path, then it is then it is actually following rectilinear motion. Uh, Now, this motion are of two types. One is uniform linear motion, where velocity would be constant but zero acceleration, and non-uniform linear motion, where there would be a variable velocity and non-zero acceleration. Right? Now let's go ahead. Another is curvilinear motion. Curvilinear motion, when the object is going through a curved path, that is known as curvilinear motion. For example, suppose you throw a stone from uh, uh, from where you're standing at particular angle, then it follow a curved path, then actually it is following curvilinear motion, right? Um, it is also of two type, planar motion and cylindrical motion. That is not necessary to describe. The basic is you have to understand that there are two type of motion: rectilinear motion, curvilinear motion, and these motion we will study in future, even in in numerical form as well as in theory form, right? Next topic is equation of kinematics. We know V equal to U plus AT, S equal to UT plus 1 by 2 AT square, V square minus U square equal to 2 AAS. We already are aware of these three formulas. Here in this slide, it is given Vf equal to Vi plus AT, D equal to Vit plus 1 by 2 AT square, Vs square equal to Vi square plus 2 AD, and D equal to 1 by 2 in bracket Vf plus Vi into T, where Vi is the initial velocity, Vf is the final velocity, A is the acceleration, D is the displacement, T is the time, right? So we know equation of kinematics. That their derivation is also very important. So this is a very simple derivation. You can see your old books also to see the derivation, or in future I will try to find out the I will make another presentation, small presentation, in which I will discuss the derivation part also, because even derivation also comes in our exam, right? Now another thing is two-dimensional kinematics in rectangular coordinate system. Suppose a particle is moving in a rectangular coordinate system. Rectangular coordinate system means in x direction and y direction, right? Then um, then the distance would be xi plus yj. I is in x direction, j is in y direction. Velocity will be x dot I plus y dot j, where x dot and y dot are uh, rate of are the first derivative of distance in x and y y direction, and acceleration is x double dot uh, uh, I plus y double dot j, where x double dot y, and y double dot are second derivative of position vector x and y, right? The next thing is work energy equation. According to work energy equation or work energy principle, the work done by the sum of all forces acting on a particle equals the change in kinetic energy of particle, which means work done by the net force is equal to final kinetic energy minus starting kinetic energy. We know work done is equal to force into distance. Kinetic energy is 1 by 2 mv square. And suppose v is final velocity and v naught is initial velocity, then final kinetic energy will be 1 by 2 mv square. Starting kinetic energy will be 1 by 2 mv dot square. So work done by the net forces is Fd. So mathematically it would be Fd equal to 1 by 2 mv square minus 1 by 2 mv dot square. Now this equation is very important because lots of numericals uh, you you are going to experience or you are going to solve using this equation. So always remember this formula, right? Now, next topic is conservative force and non-conservative force. Conservative force is basically a force with a property that the work done in a moving particle between 2 points is independent of the path it takes. Now, any force, any movement which is not dependent uh, on the path but only initial point and final point, that is conservative force. For example, force due to gravity and spring force, they both are conservative force. And non-conservative force is dependent upon path also. Uh, besides initial point and final point. For example, frictional force is a non-conservative force, and work due to gravity and um, spring force is a conservative force. Now here potential energy is important. Potential energy we know it gives a object in it tells about basically position of the body. Now there potential energy again two type spring forces of spring and force of gravity. Force of gravity we know F equal to mgh when the some object falls uh, uh, from some height to the bottom, then we get mgh. And if and force to spring is 1 by 2 kx square, where k is the spring constant and x is the movement of stretched portion of spring to restored position. That distance is known as x. So force or due to spring is 1 by 2 kx square. So these two formula you also remember because that will also be going to used in our further numericals. Now another principle is conservation of mechanical engineering, which states total energy is constant, that is kinetic energy plus potential energy equal to constant, which means if we know initial kinetic energy, initial potential energy and final kinetic energy and final potential energy, then they can be made equivalent to each other. That is initial kinetic energy plus potential energy and is equal to final kinetic energy plus potential energy. Now this formula is also used to solve numericals, but remember that this conservation of mechanical energy is applicable only for conservative forces, not for non-conservative forces, right? So conservative forces, as we know, it's spring forces due to spring or due force due to gravity is a conservative force. If there would be a non-conservative force like friction, then do not use this equation, do not use this principle. Then you have to use work energy principle, not conservation of mechanical energy. So for conservative forces, this formula is very good. Another topic is momentum and impulse. Momentum, we know the measurement of mass in motion, that is how much mass is in how much motion. P equal to mv. Impulse is the overall effect of a force acting over time. J equal to F delta T, right? J is impulse, F is force, and delta T is small time at which the force has been applied. So J equal to F delta T. Now we know momentum as well as impulse. We will be ready to understand impulse momentum principle. According to impulse momentum theorem, uh, the change in momentum of an object is equals the impulse applied to it, that is J equal to delta P, and as I have already told you, J equal to F delta T, and delta P is M delta V. Delta V is basically difference between final velocity and initial velocity. So F delta T will be equal to mv minus mu. So this is impulse momentum theorem. Now this theorem is also used in solving different numericals. This theorem was based upon Newton's second law of motion. So you remember this thing also. So now I have shared with you three principles: work energy principle, conservation of momentum, and impulse momentum theorem. Remember these three principles because they are going to be used in for in numerical solving. And the first thing, the equation of kinematics, that is v equal to u plus at s equal to ut plus 1 by 2 at square, and v square minus u square equal to 2as. So these formulas you have to remember for solving different numericals. In next presentation, um, I will discuss numericals on above topics, and then next another three topics I have to discuss: collision and types of collision, coefficient of restitution, loss of energy, and a numerical based on these three topics also. So I think I will take two more presentation on numericals related to this this the topic which I had today discussed, and then one presentation on next three topic, one or two, and numericals. This will be enough for today, right? Thanks a lot for listening me patiently. I would like, I will be putting this video on YouTube also. So I would be requesting you to, after listening, please give your remarks on YouTube itself. How do you find this presentation? What more changes you feel I should do it so that I can make online education better for you people. Um, and if you have any technical query, that would also be very good. And please, whatever remarks you give, that will be taken as attendance for you. I want every student should give their remarks about this presentation. Anything which you feel like telling about it, and I will try to have 15 to 20 minute Zoom meeting also. I think 1 or after 1 or 2 days, where we can discuss anything, any doubts of you regarding this. Okay, so okay, thanks a lot and good night. Bye.